All right, hello and welcome to today's Tech Talk on operationalizing Pyomo decision models. My name is Haley. I'm part of the NextMove team here, and I'll be your MC for today. Today's presenter is Sebastian Quintaro, or Sebas, as we call him. He is a NextMove decision scientist, and despite what he might say, a worthy chess and tennis opponent. He'll be covering quite a bit over the next 28, 29 minutes here. So we're going to make sure we get right to the content. But he's going to start with a quick orientation on the decision science data flows and DecisionOps. He'll then dive into an optimization speed run where he's going to build, test, and deploy a Pyomo decision model. And finally, we'll save some time for Q&A at the end. We encourage you to use the Q&A feature that's available at the bottom of your screen. You're also welcome to drop your questions and or comments into the chat off to the side. One note is just to keep an eye on that hosts and panelists and everyone toggle. We just want to make sure that your question or comment goes to the right audience. So with that, I'm going to disappear into the Zoom background here and let Sebas take it away.
Thanks a lot, Haley. Hey, everyone. Happy to be here. Thank you for joining. As Haley said, Sebastian, call me Sebas, whatever you prefer. And I'm going to dive right in. So for those of you that are not familiarized, what is NextMove? Here is a small diagram of our platform in which you have three components: inputs, the platform itself, and outputs. The data flow, of course, is inputs coming to the platform. The platform generates outputs. And those inputs can really be anything. They can be operational data. They can be data coming from a backend service, from a streaming service, from a database. It can be from predictions or business rules. Once it enters the platform is a platform for decision modeling. So you essentially make decisions with optimization models, for example, and those decisions are then sent to the appropriate place, right? It can be an ops dashboard. It can be a database. It can be another backend service. You get the gist. And in the NextMove platform, you have several layers that you can see here. So at the topmost layer, you have what I call the interfaces. So for NextMove, we have different interfaces for different experiences. We are a developer-first platform, meaning we do have a CLI, we have some SDK, but that doesn't mean that we're only for a technical audience. We also have a console, which I'll be using during this tech talk, in which you can share and analyze results with key stakeholders, like an ops manager, for example. Then on the platform itself, you have applications. We are not a vertical specific platform, meaning we're not a vehicle routing shop, we're not a shift scheduling shop. We offer many applications, and the heart really of NextMove is customization. So of course, you signed up for shift scheduling. That's what we're going to be doing by supporting different optimization solvers. So we have in-house solvers, Highs, for example, Pyomo, which of course is subscribed to, being supported by multiple languages. So you see how this is like a pyramid, right? Like one layer supports the other one. And at the very bottom is the secret sauce, which is our infra, ops, and testing capabilities. So again, we're going to be focusing on a shift planning application using Pyomo and Python. And most of you are probably familiar with what is Pyomo. However, doesn't hurt to remind people, it is an open source mathematical optimization layer. It does not bundle any solvers, but it does support many other ones so that you can represent different problem types. And NextMove is not a solver company, although we do have a great in-house solver for vehicle routing. We are a platform, so we're solver agnostic. We love integrating with solvers. We love integrating with optimization technologies. So with us, you can build, test, deploy models quickly. And when you combine NextMove with Pyomo, what you get is hosted decision models that can be new or existing, and you get production-ready infrastructure so that you can start providing value to the business more quickly. And how do you do that? Well, you can perform experiments, you collaborate with other people, as I said, manage version instances, monitor runs. It's a whole packed product. And because I'm always saying, what do I say? I say less show, more tell. No. More show, less tell, right? Although that's probably not proper English. I'm gonna be doing a speed run, demoing Pyomo and NextMove. And for this speed run, let me just set the stage. So we always use the FarmShare company, and the FarmShare company is a sample logistics company that delivers fresh goods from local farms to customers' homes. It is a fictitious company, doesn't exist, so don't try to look us up in the App Store. And essentially, you have multiple places of pickups, different farms. You pick up produce, dairy products, so on and so forth, and you deliver to customer homes. Okay. And there are different problems at this farm share. You can have, for example, demand forecasting to try to estimate how many orders are coming in on a weekly basis. Then you can have a shift assignment problem, which we're going to be focusing on today. And then when you decide the shifts that you're going to be assigning your workers, you send them on to do deliveries with a vehicle routing. And in this shift assignment realm, what I'm going to be focusing on is the input being number of workers and um, shifts that need to be covered. So required workers and worker availability, and the output that this model needs to produce is driver shift assignments. So you are assigning shifts. And to do that, I'm going to be using two things. So the first is community apps. From that community app, I took it and made it my own, which you're gonna check out in just a second. And I made it my own in the FarmShare company. So let me just go right into GitHub. Community apps is a place where you have some pre-built decision models. So for example, we have a shift assignment with Pyomo. And what I did, now I'm no longer save us from NextMove. Now I am save us from FarmShare. So what I did is I took this shift assignment Pyomo application, and it's a very simple Python application, and I made it my own. I made it my own in this FarmShare repo. All of this, of course, is public, so you're free to come here and follow along in the code that I'll be showing. And this is the FarmShare repo, where I have two services right now, vehicle routing and shift assignment. So shift assignment, as I said, is based on Pyomo. And if I take a look at the code here in Python, let me just quickly run you through. We're setting up some decision variables. We're setting up an objective, and we are coding some constraints. The objective is to maximize the sum of the preferences of the assigned shifts. If I take a look at a sample input that we have here, each worker has a preference for different types of shifts. And if I take, so for example, this one says dairy Monday early. Let me just go ahead to the shifts. Let me go to the shifts. And so this shift is called dairy Monday early. Different workers want different shifts, which is fair. But now I got a requirement from ops, and ops said, hey, we're looking into optimizing the workers that we're paying. So what I did is, let me just try something before going live with an idea. I want to go ahead and try this idea using the NextMove infrastructure. So what I did is I opened a pull request, and I am changing the objective function to minimize workers with assignments, meaning minimize number of workers. Okay. Haley was kind enough to give me an approval. And if we take a look at what files are changing, I can see that my objective function is no longer going to be maximize the preference, but rather the objective function is to minimize the number of workers. And for that, I'm introducing a new decision variable, and I'm introducing a couple of constraints so that I can make a relationship between my new binary decision variable with the other variables. Okay. Let me go ahead and merge these changes actually. Cool. So after merging these changes, if I go to actions, what you'll see here is that a workflow run kicked off. And this is a CI/CD pipeline called shift assignment. So let me just go there. And what this pipeline is going to do is it's going to kick off an acceptance test. An acceptance test is a test in which you give go, no-go criteria for a set of changes. So what I'm doing is I have a set of metrics that I'm controlling. And for each metric, I'm comparing my new code versus the code that is already stable or in production. And I'm going to go ahead and use console to do that. And this was actually done pretty quickly. So really fast, what we're doing here is that we are using the NextMove CLI. If you take a look at this code, I'm using the NextMove CLI to push my application to push my new code to the NextMove cloud. I am creating a new version, which is tagging the code. Then I am updating an instance. After I'm done with that, I'm gonna go ahead and start an acceptance test by running this Python script called CI/CD tests. So if I take a look at my code, which is now merged, my Python script uses our Python SDK or the NextMove SDK, right? I'm not Sebas from NextMove anymore. It uses NextMove's Python SDK, and it's quite compact. I am launching a new acceptance test, and the metrics that I'm using to compare are read in from a file called acceptance test metrics.json. Cool. If I take a look at that file, it's a set of metrics in which I am comparing in the output. I'm saying, okay, the value needs to be less than or equal in the new change. The number of variables needs to be less than or equal. More important, I'm interested in worker assignment rate and the merged availability usage. It turns out that the workers have a certain availability. When I merge availabilities together that are back to back, I'm trying to get a measure of how efficient are my assignments. So going back to my action, I got a nice summary here saying, I pushed my app to the cloud. I created this new version called 7A5. It's just a commit hash. And I updated my development instance to this new version. I started my acceptance test, and you can click here to see the results. So let me just go ahead and click that. It's this one. So DecisionOps is a process that we like to think of it as automatically, we call it, it's an automatic process manually audited. So my CI/CD pipeline kicked off this automatic process that launched the acceptance test. Now I am reviewing these results live. So what I'm comparing is my baseline instance is called production, and it's on version V010. And my candidate instance is going to be development, which I now updated to this new version that I just pushed. And I'm using an input set ID called acceptance. And an input set is basically a collection of files. That's it. It's a collection of JSON files. You don't need to know more than that. For each input, so for each file in the input set, I'm going to be running baseline versus candidate, and I'm going to take a look at the comparison that is here. Okay. So the first thing that calls my attention is that I see a couple of red metrics, meaning it did not pass the test for that metric. And if I take a look at them, it's custom variables, so the number of decision variables in my model, and custom constraints, the number of constraints in my model. And this actually makes sense because what I'm doing from the code, if you remember, is I'm adding a new decision variable or decision variable set, and I am adding some new constraints. So actually, what this tells me is, hey, you should have flipped the symbol, or you don't even need to check custom variables and custom constraints altogether. But this is okay. Like this makes sense. If I take a look at the worker assignment rate, though, I can see a slight improvement. So if I change my objective function, I can see that I am using 75% of the workers on average. However, that change is not statistically significant. So from a statistics point of view, I am not actually achieving what I want. However, if I take a look at the availability usage, okay, it's also not statistically significant. So I'm getting some slight improvements, although they're not essentially night and day kind of difference. But it's okay. I made sure that at least the code is running. I get a slight improvement, so I can go ahead and launch that to production. Before doing that, however, if you remember, Pyomo, for those of you that are not aware, Pyomo does not bundle any solvers. So the Pyomo integration with NextMove does come with pre-installed CBC and GLPK solvers. If I take a look at what's underneath this acceptance test is this batch experiment. And the batch experiment is the actual comparison of the two instances, and they give you all the runs for all the inputs in the input set. If I take a sample look at any of these runs, I have the details of my run, the input that I used for that, and the result. So, okay, this had an optimal solution and it used CBC because that's the default solver that this app is using. So what I'm actually going to do now is I want to know what happens if I use GLPK. So let me just go ahead and run a test to do that. Let me create a new instance and let's call it GLPK new objective. Sure, why not? The version is, oh my God, what's the version? 7A57. This is the one. And the provider is an option. If I go take a quick look at my Python code here, main.py, we have some command line arguments, and you can see that we have duration, provider, default is CPC. So I'm going to use the provider GLPK. And let's just cap this at 5 seconds. These are actually very small examples because I don't want to bore you to death waiting for this to run. So intentionally, these are small inputs. And let's create this instance. So now I want to go ahead and compare development, which I know as a default uses CBC, against GLPK new objective. Let me create a new batch experiment. So let's just call this batch experiment new objective. Why not? The input set, I'm going to use an input set for batch experiments, and I'm going to compare those two instances, development versus GLPK new objective. Again, what this does is that it will take each of those inputs in the input set and run them against both instances, and it will show you a nice comparison. Why is an acceptance test based on a batch experiment? Because the batch experiment has the comparison, and then the acceptance test will say, okay, for each of the metrics that you're interested in, doesn't have to be all of them, just the ones you're interested in, I'm going to give you a green or red sort of visual that is nice. Oh, completed. That was fairly fast. Cool. So if I'm comparing solvers, I can see that the value here doesn't have a visual and it's nan, not a number. And if I take a look at the runs actually to understand why, let me look at a run that has the value nan, like this one. Okay. Let me open that on the side. Result. Okay. So that input wasn't feasible. So it makes sense that you don't actually get a comparison for the values because if you're doing a mean and you have a nan number in there, you're not going to be able to do it. But if I'm comparing those two solvers, like literally a really rough proxy would be maybe to take a look at the duration. So the total execution duration is the total time it takes to formulate the problem and solve it. And we can see here that CBC is actually much more compact than GLPK. So GLPK is probably struggling in a couple of these instances. Solution duration is just the time the solver takes. And there's a bit of overhead from setting up the problem and like reading the results. That's what all of this entails. And taking a look at just like raw solver time as reported by Pyomo, CBC seems to be a bit better here. Of course, like doing a comparison just due to runtime, definitely not recommended. We need a much more disciplined study to actually determine which solver is better. But the good thing is that because you can customize all the metrics that you're interested in, for example, here I'm saying the number of constraints that I'm using, the number of variables that I'm fixing, you can get all sorts of metrics from the solvers themselves using Pyomo interface to do that comparison. So, okay, what this tells me is, one, this change looks good to go to production. The new objective, I mean. And two, I actually want to go to production with CBC for now because it seems to be a bit better. So let me go back to my presentation here. And I know this was maybe a lot. So let me just do a recap of what happened here. So one, I created a custom Pyomo shift planning application, which I started from the community apps repo, and then I made it my own. I customized it, and then I deployed that application to NextMove Cloud, of course, making runs to my custom endpoints. We merged some code, which then kicked off a GitHub workflow, and that ran an acceptance test that we reviewed, and we said, looks good. Let me just go ahead and try another solver with a batch experiment. All that's left now is to flip the switch, go to prod. But because we're all about de-risking going to production, before actually flipping that switch, you want to go ahead and do an online test. Oh, sorry. An online test is another type of test in which you're testing with information that is coming into your service in real time. And what we have here is a sample of a shadow test. A shadow test is a test in which you have a baseline instance, a candidate instance, and that candidate is deployed in parallel to your baseline. So whenever traffic hits your baseline, it's also going to hit the candidate. When you analyze the results in the same view as a batch experiment, what you'll be able to tell is what would have happened if my candidate was deployed to production. One example of this is I may have a bug that I'm not seeing in my optimization model. So if I take a look at my candidate runs after I'm done with my shadow test, and I see a lot of failures, failure, then I know like, whew, I'm glad I didn't put production down. I made a safe test. And if you're just tuning in or you recently tuned in, that's okay. What I want you to take away from this talk is one big idea, and is that you can confidently accelerate the real world impact of your decision model with DecisionOps. And I have two words highlighted here, confidently and impact. Confidently, because the fact that I'm doing testing with statistical significance and I am actually trying things before trying them live gives me the confidence that I might break production, but I'm lowering the chance of doing so. And because I have these great tools, you saw that I just merged a PR, everything was done super quickly. I can spend more time on the modeling and more time on understanding how to solve the business problem, meaning I'm going to have a higher impact in the business. So this is what we call this decision ops process of developing, testing, deploying, operating, and going back to developing, testing, et cetera, et cetera. Thanks a lot for your time. And I think we can do some questions and answers.
And that's the time when I return. So thank you, Sebas. We do have a
Yeah.
couple of questions that came in that I will send your way. So one of the first ones actually is, so during the demo here, you've shown support for GLPK and CBC. Can you speak to other support for other solvers, open source or commercial, that might be that comes along with the integration that you showed here today?
Yeah, definitely. So we included CBC and DLPK out of the box because one, they're open source, two, fairly easy to install. But any solver that Pyomo supports, commercial or open source, we can support as well. It can be Gurobi, Cplex Express, or other open source ones like Heis, etc. We can do that so with no problem.
Great, excellent. And then, Sebas, there's another question that came in around, can you kind of, this might be more of a high level question, I think, as I'm reading it, but kind of give an example of how NextMove might integrate into common like logistics tech stack architectures?
Yeah. So if I go back actually here, this is actually a good example of in your real world application, you can do some forecasting, which you can then feed into an optimization model, which you can then feed into another optimization model, sort of like doing sequential decision analytics. And this can really be anything, as I said. This demand forecasting, it can come from an AI model. Then you can feed it you can feed those results into a data stream that then the shift assignment process is listening to and is subscribed to the data stream. But of course, that's like quite technical. For other more tools that are focused on dashboards, for example, it can be like I'm getting some information from my orders in a spreadsheet. I can load that spreadsheet to my platform, and then from that platform, I make a call to the NextMove endpoints, right? So what would NextMove do? Take the data, make the decisions, and dump them or return the results somewhere. So really, this platform honestly can integrate with any tech service in general.
Excellent. And I saw a couple comments, questions come in on the side just about the recording today, but just so folks are aware, we will send this out and share via email today. So keep an eye on your inbox for that. I think there's one more Sebas that I'd like to slip in. But somebody has commented on noticing that we had some models written using OR tools and wondering if they can infer that NextMove is a modeling method agnostic, so Pyomo, OR tools, both, etc.
Yeah, that makes sense. So I did make a comment on solver agnostic, but you can actually extend that to be we at NextMove are solver agnostic and modeling agnostic as well. Um, I do remember talking to a customer once, which they said, "Hey, I'm actually coding my own vehicle routing algorithm, like, but you claim that yours is great. Do I have to use yours?" I'm like, no. Like, don't take it from me. Honestly, you can just go ahead and do batch experiments and compare your model to the solver or heuristics that we have and just make it your own, right? So everything is possible.
Excellent. All right, I think we're going to wrap this up. We've got two more slides here before we officially close out. So just one call out here. As Sebas mentioned, the community apps repo, we'll share this link with everybody over email when the recording is available today. But feel free to check that out. And I've snuck in a little preview that will be in a NextMove console near you a little bit later today. You'll be able to access all of the apps that are available in the community repo inside the NextMove console, so you can just get up and running right away and start experimenting with some of what Sebas showed today. So that's available through our cloud console, and we'll share that link with everybody as well. And then finally, Sebas ended the presentation showing you a shadow test. We recently released another form of online or production testing called switchback testing. So it's kind of like A/B testing for decision models, but it accounts for network effects and all those goodness, all that goodness. It's going to be presented by the Nicole and Dirk, two of our engineer team members who are fantastic. That presentation will be on Thursday, February 15th. We hope that we'll see you there. Um, Thank you so much for joining today, everybody. Sebas, thank you for the amazing presentation.
Yep, thank you.
Until next time.
All right, take care, everyone. Bye.